Kinematic analysis, vectors, magnitude, direction. Example, displacement, velocity, acceleration, momentum, force, torque. A bar is equal to mod A bar dot mod A bar A cap. A mod A bar is representing magnitude. A cap is unit vector direction. Graphical representation of a vector, length of line, magnitude, head of line, direction, tail, head of straight line. R bar is equal to P bar plus Q bar. Method to calculate R, algebraic. R square is angle between P and Q is theta. R is resultant alpha. R square is equal to P square plus Q square plus 2PQ cos theta plus 2p, and this is q sin theta, this is q cos theta. R square is equal to p square plus q square plus 2pq cos theta. Tan alpha is equal to 2 sin theta. 2 is equal to tan alpha is equal to q sin theta by p plus q cos theta. R bar is equal to p bar plus q bar is equal to q bar plus p bar. First R bar, okay, joining, just a joining from tail to tip, they must meet. Vector diagram, equilibrium, f1 f2 if closed cycle, then a force used for force and couple calculation. Unit vector in any direction, simple only, rotation cos theta y cap cos theta plus j cap sin theta. OB cap is equal to minus I cap cos alpha plus j cap sin alpha. OC cap is equal to minus j cap cos beta plus I cap sin beta. Cross product or curl, cross product or curl. A bar cross B bar is equal to A bar dot B bar sin theta n cap. I cap j cap I j k a b c d e f. I cross j, like clockwise it is positive, I j k anti-clockwise negative. I cross j, k cap j cross I minus k cap, k cross I cap j cap I cross I cap 0. Expression for relative velocity and relative acceleration between 2 points on a rotating or oscillating link. ER cap radial direction, which is which is like this. ET cap tangential direction, which is like this. Tangential upwards has alpha and omega in the same direction and counterclockwise. ER along the link, ER cap along the link, ER high cos theta plus j sin theta. ET cap perpendicular to the link, ET is equal to j cap cos theta minus I cap sin theta. J cap cos theta minus I cap sin theta. Position vector of point A with respect to O is equal to OA bar. OA bar is equal to mod of OA bar into OA cap. OA bar is equal to RER cap. OA bar is equal to R I cap cos theta plus j cap sin theta. Velocity of point A with respect to point O. VA by O is equal to d by dt of OA bar is equal to d by dt of R I cap cos theta plus j cap sin theta. VA by O is equal to R d by dt of I cap cos theta plus j cap sin theta is equal to R into I cap minus sin theta d theta by dt plus j cap cos theta d theta by dt. D theta by dt, we can write it as r omega is equal to r omega minus I cap sin theta plus j cap cos theta. VA by O is equal to r omega ET cap, which means r omega will be in tangential direction. V bar A by O is equal to OA omega. V bar A by O is equal to ET cap. Relative velocity between 2 points on a link which is in angular motion will have only one component. To represent the relative motion between 2 points on rotating or oscillating link graphically, we should draw a line perpendicular to the link whose direction will be decided by omega. Acceleration of point A with respect to O. A bar A by O is equal to d by dt of V bar A by O. d by dt of OA omega j cap cos theta plus minus I cap sin theta is equal to OA omega d by dt of minus I cap sin theta plus j cap cos theta plus minus I cap sin theta plus j cap cos theta d by dt of OA omega. A bar OA by O is equal to OA omega minus I cap cos theta d theta by dt plus j cap minus sin theta d theta by dt. OA into d omega by dt of minus I cap sin theta plus j cap cos theta. D theta by dt we can write it as omega, and d omega by dt we can write it as alpha, which is angular acceleration. Finally we will get expression like this, which is nothing but a bar a by o is equal to oa omega square minus er cap plus oa into alpha et cap. Relative acceleration between 2 points on a rotating or oscillating link have two components, normal or radial component. A bar A by O n is equal to OA omega square of minus ER cap. Minus ER cap will indicate it will always act towards the reference point, and in order to represent graphically, we should draw a line parallel to link towards the reference point of configuration diagram. Tangential AT bar is equal to OA alpha ET cap. To represent it graphically, we should draw a line perpendicular to the line link, and its direction will be decided by angular acceleration alpha. Angular acceleration normal and tangential components are mutually perpendicular. A by O is equal to A bar normal A by O plus A bar tangential A by O. A bar like magnitude of A bar A by O is equal to root of A n A by O square plus A t bar A by O square. F centrifugal is equal to mr omega square reaction of centripetal pseudo force, disturbing force. Configuration diagram. Link OA is like this, then VA bar will be like this, OA omega square will be like this, alpha, then V bar OA is equal to OA omega ET bar, it will be like this, theta, if triangle is drawn like this, then with horizontal it will be 90 minus theta. Acceleration O small a is equal to OA. This diagram V is equal to VA by O is equal to OA omega. Acceleration diagram A bar is equal to AO bar plus A by O bar is equal to A by N bar A by O plus AT bar A by O. OA omega square of minus ER cap plus OA alpha ET cap. From O it is this is theta, in that direction inward OA1, and perpendicular to it OA alpha. OA alpha, yeah, the resultant of these two A by over AA. Okay, from this we can draw velocity diagram and acceleration diagram like this. Here acceleration alpha and omega are in same direction, so OA alpha is in this direction, and retardation alpha and omega are in opposite direction, which means omega is in this direction. OA1 is like this, OA1 is like this, then AA by O will be like this. Omega is equal to constant. As omega is equal to constant, alpha is equal to 0. Velocity diagram, omega is in this direction, so perpendicular to it, OA omega. Acceleration diagram, there won't be any component perpendicular to this, only radial component, OA omega square inside. So theta at an angle AT by O is equal to 0, as alpha is equal to 0. Alpha exists, omega 0. Velocity diagram, OA is equal to 0, VA by O is equal to 0, OA omega is equal to 0, omega is equal to 0. Acceleration diagram, OA alpha. OA alpha in this direction. So A and A by O is equal to 0 as omega is equal to 0 at that point. Translational rectilinear plus curvilinear. Rectilinear translational. Rectilinear translational. LALB is a straight line. T is equal to T1, T is equal A, B, B, B dash. T is T at T1 plus delta T. VA bar is equal to VB bar is equal to VCM bar. AA bar is equal to AB bar is equal to ACM bar. Whenever there is higher pair, draw a common tangent and a common normal. Example, gear and pinion, cam and follower. At point of contact in any subject. At point of contact, common tangent, common normal. Common normal is known as line of action. Common tangent is known as line of slip. Curvilinear translation. A B L A L B arc of circle. Velocity V A acceleration always parallel to common tangent A bar ACM VCM square by R into the okay. Always parallel to common normal from R smaller center of curvature perpendicular to ACM. Okay, in case of curves, acceleration R2. In case of curves, acceleration like if it is straight line, only ACM will be there. V slider by infinity is 0. But in case of curve, ACM and VCM by R square both will be there. Example, ACM VCM by infinity is equal to 0. Capital R is equal to small r plus h by 2. R tends to infinity. In case of flat surfaces, only one acceleration as R tends to infinity. Rolling motion, rotation plus translation, omega VCM at T1 it is like this, and T at T1 plus delta T it is like this. SCM is distance traveled. P2 Q2 is equal to Q2 P2 dash. Pure rolling. That is SCM is equal to R theta. Means this distance moved is how much it has rolled. SCM is equal to R theta only in case of pure rolling. DSCM by dt is equal to R d theta by dt. VCM is equal to R omega. ACM is equal to R alpha. Initial location is P2. That is moved by P2 in time t plus delta t. Q2 in his new location. P2 Q2 is equal to Q2 P2 prime for pure rolling. Velocity analysis at every point VCM is straight line and R omega is in direction of omega and tangential direction. VCM is equal to R omega at point C. Here no slipping, V point C is equal to 0. And as VCM and R omega in opposite direction. Degrees of freedom is equal to 1 pure rolling without slipping. V point A is equal to VCM and R omega in same direction. V point A is equal to R omega is equal to 2 VCM. V point P which is here at an angle theta, root of VCM square plus R omega square plus 2 VCM R omega cos theta. Vp is equal to VCM into the root of 2 into 1 plus cos theta. 2 into 1 plus cos theta. For point B, point B is equal to V point D is equal to root VCM root 2. case 2, VCM is not equal to R omega, V point C not equal to 0, rolling with slipping. Either VCM greater than R omega, forward slipping, SCM greater than R theta, degrees of freedom is equal to 2, or VCM less than R omega, backward slipping, SCM less than R theta, degrees of freedom is equal to 2. Acceleration analysis. As VCM is given towards right, omega is in clockwise direction, VCM and ACM are in same direction, alpha and omega is in same direction. Pure rolling, AC net is equal to R omega, AC net is equal to R omega square, that means centripetal. ACM is equal to R alpha for pure rolling. If this is replaced by curve, then VCM square by Kepler will be added, which is perpendicular to ACM at all points. As here it is linear, plane here, we doesn't have to bother about this. AP bar is equal to ACM bar plus R omega square of minus CR cap plus R alpha ET cap. R alpha ET cap. ACM is in this direction, R omega will be here at P, R alpha will be here. So resultant of these two will be like this. From this ACM and between resultant of these two will be final resultant is OP. Okay. From length we can find xp is equal to root of xp dash square plus p dash p whole square plus as theta and pi is known, op square is equal to x square plus xp square minus 2 ox xp cos of theta plus pi. Example A. VA bar is equal to VB bar translational rectilinear. Here it has gone from A to A dash about 0.1. Here only rotation. We had to take 2 points on the link. VA by OA is equal to VB by OB is equal to constant is equal to omega. V point O is equal to 0, center of rotation. Take another where A and B are on opposite side. VA by CA is equal to VB by CB is equal to constant omega. Method 2 VB by A is equal to VB bar minus VA bar. B by A reference point, A is reference point. AB omega ET cap one component for relative velocity is equal to VB of minus J cap minus VA of plus J cap. AB omega ET cap is equal to VB of minus J cap plus VA of minus J cap. AB omega is equal to VB plus VA. ET cap is equal to minus J cap. Link AB in general or plane motion. Link AB in general or plane motion. Different VA is like this, VB is like this. From superposition, general motion is equivalent to translation plus rotation. Translation is nothing but rotation about infinity. General motion is equivalent to rotation about I center. AB from here to here translation, then rotation A1 B1. Okay, general motion is equivalent to rotation about I center. I center of rotation is a point in plane of motion about which general motion can be assumed as rotation for velocity. I center for acceleration is not in syllabus. Okay, link AB is in general motion. Rotation about I center. X y z omega cap is equal to minus k cap by Fleming's right hand rule. Rule VA by IA is equal to VB by AB is equal to VC by IC is equal to constant omega. The ecenter of rotation for velocity will exist in direction perpendicular to velocity vector. of any point on link in the plane of motion. The axis of polar to plane of motion is known as instantaneous axis of rotation and passing through eye center. L eye center centroid, locus of eye center is centroid curve, locus of eye axis of rotation axoid surface. Eye center omega, locus of eye center centroid. The instantaneous velocity of eye center is 0. Locus of eye center is central. Locus of eye axis of rotation is axoid. Common eye center. If two links are connected with R pair, the center of R pair will be eye center. The center of R pair will be for R pair is revolute pair. Link X, link Y joined at IXY. Omega X V over omega Y V bar. If links are rotating in same direction, use negative sign. If they are moving in opposite direction, use positive sign. Like for calculation of rubbing velocity, we have to write relative velocity. Now if they are in same, r pin into omega x minus omega y. If they are in opposite direction, r pin into omega x plus omega y, rubbing velocity of pin. If a link is sliding over another link, rectilinear translation or p pair, the eye center will exist at infinity in plane of motion in a direction perpendicular to the velocity vector at any point. Like in this plane at anywhere infinity, va bar is equal to vb bar. A and b are here. If a link is sliding on curved surface, the center of curvature will be eye center. The center of curvature is I12. VA by I12 A is equal to VB by I12 B is equal to constant is equal to omega. If a link is rolling with slipping over another link, the eye center will exist somewhere along common normal drawn at point of contact. Common normal drawn like if VA is like this, then common normal is like this. Common normal VA common normal eye center will exist somewhere along common normal drawn at point of contact. Omega I VA by IA is equal to VC by IC is equal to constant omega. If VCM is greater than R omega, if VCM is less than R omega, then it will be in the middle. VA by IA is equal to VC by IC is equal to omega. If VCM is equal to R omega, it's obvious that C will be the eye center. If not, we have to do like this. It will be somewhere here, it will be somewhere here. These are the workbook problems. We have to visualize everything. If a link is in pure rolling without slipping, the point of contact will be eye center. Pure rolling is on VCM eye center P point of contact. Total kinetic energy is equal to translational kinetic energy plus rotational kinetic energy is equal to half m VCM square plus half ICM omega square is equal to half mr square omega square plus half of half mr square omega square. Total kinetic energy is equal to 3 by 4 mr square omega square. If omega and VCM is present, rotation about center of mass. Total kinetic energy is equal to rotational kinetic energy is equal to half of IP omega square about a point P. Total kinetic energy is equal to 3 by 4 mr square omega square. If only omega rotation about eye center. VA by IA is equal to VB by IP, IB is equal to VP by IP is equal to VD by ID is equal to omega. This is ID, IA, IP, the perpendicular to velocity vectors. If VCM is equal to R omega, on the point VCM greater than R omega outside at common normal, VCM less than R omega inside at common normal icenter. If string and pulley case, if string and pulley cases, the point where inextensible string enters into pulley is an icenter. String no change in length. String no change in length. Here string where it enters is icenter. Okay, this is again workbook question. If a link is in rotation, the center of rotation will exist on link itself. If a translatory component of velocity will be added to the rotating link, center of rotation will be shifted from the plane of motion known as icenter. Magnitude of and direction of omega will not change. Acceleration diagram. AB bar is equal to A bar plus A bar B by A. Normal and tangential components. AB bar is equal to AB omega square minus CR cap plus AB alpha ET cap. Okay, Taylor and vector addition. From vector addition, we can directly get, that is what he is saying. Minus CR cap always acts towards reference point, and to represent graphically, we should draw a line parallel to the link towards reference point. Minus ET cap, to represent it graphically, we should draw a perpendicular line. Okay. ACM is equal to R of alpha R omega square, direction decided by alpha. A relative velocity R omega, direction decided by omega. Okay. Icentral in mechanism. If there are n number of links in a mechanism, then possible number of icenters is nc2 is equal to n factorial by 2 factorial into n minus 2 factorial is equal to n into n minus 1 by 2. If n is equal to 4, number of icenters is equal to 4 into 3 by 2 is 6. 1 2 1 3 1 4. Like if one is fixed, absolute icenters 2 3 2 4 3 4 are relative icenters. If n is equal to 6, number of icenters is equal to 6 into 5 by 2, which is 15. 1 2 1 3 1 4 1 5 1 6 are absolute icenters. 2 3 2 4 2 5 2 6 3 4 3 5 3 6 4 5 4 6 5 6 are relative icenters. Absolute icenters only first row. Relative icenters 2 3 is equivalent to 3 2 2 4 is equivalent to 4 2 3 4 is equivalent to 4 3. Properties of icenters in mechanism. Between any two links in a mechanism, there will be an icenter. Example, link x and link y, ixy is equivalent to iyx. About an icenter, two links can be assumed to be in motion. Example, about xy, link x and link y is assumed to be in motion. Absolute icenters, icenter with respect to fixed link. Absolute icenter with respect to fixed link. Relative icenter are with respect to moving link. Yeah, absolute only one link will be in rotation about absolute icenter. Both links will be in rotation about relative icenter. Significance of a absolute icenter, use it to predict the direction of angular velocity of any link. Significance, use it to determine magnitude of any velocity of any link. Of angular velocity of any link. A icenter is a point which exists simultaneously on two links, whereas in actual it may lie beyond the physical boundaries of both links. Angular velocity theorem. Since a single point will always have only one velocity in magnitude as well as in direction, the velocity of icenter when it is assumed as a point on first link with respect to fixed link will be equal to velocity of same icenter assumed as second link with respect assumed on second link with respect to fixed link. This is angular velocity theorem. Corollaries. Corollary 1, if absolute icenter exists on same side of relative icenter, then the corresponding links will rotate in same direction. If absolute icenters exist on opposite of relative icenter, the corresponding links will rotate in opposite direction. Like for example, I is here, A, B are here, then they will rotate in they will have same direction, rotate in same direction. If absolute icenters exist on opposite side of relative icenter, like we can see from example, we can understand this completely. Location of icenters in mechanism. Arnold-Kennedy theorem or three icenters in line theorem. If three bodies or links are in relative motion may or may not be connected, the three icenters will always be collinear. N is equal to 3, number of icenters is equal to 3. 3 into 2 by 2, 3. Sun fixed. Center of earth is at center of sun. Center of moon is at center of earth. The third icenter lies on the line joining the centers of earth, sun and earth. 4-bar mechanism. N is equal to 4. Number of icenters is equal to n into n minus 1 by 2 is equal to 4 into 3 by 2 is equal to 6. 1 2 1 3 1 4 2 3 2 4 3 4. Let omega 2 is equal to known. By Kennedy's theorem, draw a rough circle of any radius and divide the circumference into parts that is equal to number of links. Like 1 or 2, 3, 4 in a circle. Draw 1 or 2, 3, 4. If you want to know, like we can look at 1 2 I23 I34 I14 easily. To get I13 we have to go from 1 2 2 3 or 1 4 4 3. So 1 4 and 4 3 draw a line, 1 2 and 2 3 draw a line, their point of intersection will be I13. To get I24 we can get either by using 1 4 1 2 draw a line, 1 2 1 4 draw a line, then 4 3 and 2 3 also draw another line, we will get I24. Vi24 is like this. We omega 3, okay, let omega 2 is equal to known. Observation. Intersection of extensions of link 1 and 3 is I24. Intersections of extensions of link 2 and link 4 is I13. Link 2 and link 4 is I13. Note, in 4-bar mechanism, the input and output link 2 and 4 will be in rotation and oscillation, whereas coupler will be in general motion. OA omega. OA is equal to question mark. VA is equal to OA omega. Angular velocity of link on which point A exists. OA point whose velocity is to be calculated. A is point whose velocity is to be calculated. O is center of rotation of link on which point A exists. Let omega 2 is known. Omega 3 is equal to question mark. Vi23 I23 Vi23 is here. Let's first assume it to be on a link 2. On link 2, then I23 is on link 2. Then I12 absolute I center I23 omega 2 is equal to Vi23. So, like omega 2 plus or minus omega 1, as omega 1 is 0, we can remove it. Equal to Vi23 on link 3. Vi23 on link 3. We can take on link 3 I13 I13 I23 into omega 3. I13 I23 into omega 3 plus or minus omega 1 is 0. So finally we will get I12 I23 omega 2 is equal to I13 I23 omega 3. Omega 2 by omega 3 is equal to I13 I23 I12 I23. These are distances. I12 I13 are absolute icenters, I23 is relative icenter. Absolute icenters are in opposite side of relative icenter, then corresponding links will rotate in opposite direction. Relative icenter is 2 3. I13 and I12 are in opposite direction, so both will be in opposite direction. Omega 2 and omega 3 is prescribed as counterclockwise, as omega 2 is in clockwise. Omega 3 is equal to none, omega 4 is equal to question mark. The same process we will follow. I34 is equal to I13 I34 omega 3. The I34 is assumed on link 3 only, is equal to I14 I34 omega 4. Link I34 is on link 4 only. Omega 3 by omega 4 is equal to I14 by I14 I34 by I13 I34. Omega 2 is known, omega 4 is equal to question mark. Vi24 is equal to Vi12 I24 omega 2 is equal to I14 I24 omega 4. I24 is on link 2 only. I24 is on link 4 only. Omega 2 by omega 4 is equal to I14 I24 by I12 I24. This is again workbook question. Special case in 4-bar mechanism. Input and output link are parallel. Let omega 2 is given. Omega 2 is given. Then I23 is equal to I12 I23 plus omega 2 is equal to I13 I23 omega 3. Omega 3 is equal to I12 I23 omega 2 by I13 I23. Here, but here, if you see, as 2 and 4 will not intersect, I13 will be at infinity. So omega 3 is equal to I12 I23 omega 2 by infinity. Omega 3 is equal to 0. Observation: when input link and output link are parallel, the angular velocity of coupler means this connecting rod, is always 0. I24 is equal to I12 I24 omega 2 is equal to I14 I24 omega 4. Omega 4 by omega 2 is equal to I12 I24 by I14 I24. And I12 I24 I23 and I14 I24 I24 are in similar triangle. So I12 by I23 by I14 I34 is equal to I12 I24 by I14 I24. Similar triangles, okay. From equation 1 and 2, omega 4 by omega 2 is equal to AB by DC. AB DC, okay. L output omega output is equal to L input omega input. This I'll tell you one easiest method for this. If this is omega 2 and this is omega 4, VB bar will be like this, VC bar will be like this, and perpendicular to these AB rods and VC rods. one condition for this rod to be rigid is along this rod, components of velocities should be equal, but here angle is same. So vb cos theta v is equal to vc cos theta. That means vb is equal to vc. From that we can directly say b omega 2 is equal to cd omega 4. This is the easiest way, but this concept you should know. Vc bar is equal to vb bar plus VC by C by V bar VC bar is equal to VB bar plus BC omega 3 ET cap. VC bar is equal to VB bar, therefore direction and magnitude is same. Again workbook questions. Special case in single slider mechanism. Crank is perpendicular to the line of stroke. V slider Vi24 R omega 2 I13 at infinity I14 at infinity. Vi23 is equal to I12 I23 omega 2 is equal to I13 I23 omega 3. Omega 3 is equal to I12 I23 omega 2 by I13 I23. As I13 is at infinity, omega 3 is equal to 0. Omega 3 is equal to 0. But obviously this point is moving in a straight line. Angular velocity of connecting rod is equal to 0. I24 is equal to I12 I24 omega 2 is equal to I14 I24 omega 4 is equal to V slider. Again here also you can directly use the concept of along the velocity along the rod velocities components should be equal. We will get the same result. V slider is equal to crank radius into omega crank when crank is perpendicular to the line of stroke. VC bar is equal to VB bar plus VC by B for link to here omega 3 is 0. So VC bar is equal to VB bar. Good questions. Maximum speed during return stroke. Okay. Ratio of maximum angular velocities of slotted bar during cutting and return stroke. Vs for max cutting is equal to Vs for max return. C plus R into omega 4 max is equal to C minus R into omega 4 max return. Omega 4 max cutting by omega 4 max return is equal to C minus R by C plus R. C minus R by C plus R less than 1. So omega 4 max in cutting less than omega 4 max in return. Coriolis component of acceleration. Here this is sliding and this slotted bar is rotating. We have already seen this, but we didn't study about Coriolis component in depth. Link to slotted bar. Link 3 slider. B2 B3 okay are instantaneously coincident points. Object U frame V result V relative. Object V frame omega result A Coriolis. Object omega frame omega P alpha result omega alpha gyro. B2 prime A is due to VB3 by B2. AB3 is due to A Coriolis. AC bar is equal to 2 omega slider bar across V sliders slotted bar relative to slotted bar. AC bar is equal to 2 omega 2 bar across VB3 by V2 bar. AC magnitude is equal to 2 VB3 by V2 into omega 2. Direction AC cap is equal to omega bus bar cap cross V cap slider slotted bar. To find out direction, rotate V relative by 90 degrees in plane motion. The sense of rotation must be same as omega slotted bar. If omega slotted bar is in clockwise direction, rotate V relative by in clockwise. If omega slotted bar is in counterclockwise, rotate V relative in counterclockwise. Uh, V is equal to R omega, V bar is equal to omega bar cross R bar. V is equal to R alpha, A bar is equal to alpha bar cross R bar. AC is equal to 2 V omega, AC bar is equal to 2 omega bar cross V bar. T is equal to F R, T bar is equal to R bar cross F. T is equal to I omega omega P. T bar is equal to I omega P bar cross omega bar. Example, V relative is in this direction, omega 2 is in this direction, then A component will be V bar rotated in 90 degrees about in omega 2 bar. Or we can directly write plus K cap cross my plus K J I cap minus I cap. Okay, so we can get all this. This velocity and acceleration diagram, just we have to draw velocity diagrams from joining, like from diagram itself we can say what it is, from diagram itself, from lengths we can say how much is acceleration, how much is velocity. Acceleration diagram, to draw this must draw velocity diagram first. First draw velocity diagram, then draw acceleration diagram based on length. Then for final velocity we can calculate length, and direction also easy only. Okay, these are directions we can draw, and from that we can get construction. Let's see later.